First chapter, matter measurement and problem solving. And there's some really important stuff in this first chapter that hopefully for many of you is a review, but we need to get solid on it. And so we're going to take the first week and we're going to cover this chapter. So what do you think? What do you think is the most important idea in all of human knowledge? We could probably debate that for hours. I'm sure many people have many different ideas. If we limit ourselves just to thinking about scientific answers to this question, it would probably be this. The properties of matter are determined by the properties of molecules and atoms. This is the core of chemistry. We study atoms and molecules and what they are like because that helps us to understand why my cell phone case is bright pink, my favorite color. Why is the desk, the bench top, black? Why is it hard and not squishy? The properties of the matter come from the properties of the individual atoms and molecules. Those atoms and molecules determine how the matter behaves. If you change the atoms and molecules, you change the matter. So we think about water. We're familiar with water. Hopefully most of us have taken a shower in the last couple of days at least. The properties of water come from the properties of the water molecules. Sugar has very different properties than water, right? You'd never take a shower in sugar. It's just really not even possible, and it wouldn't do much good. Why are those two things so different? Because the molecules themselves are different. So when we can understand matter at this molecular level, at the small particle level, that allows us to have control over that matter. We can alter the matter to change the properties of it to suit our purposes. And so this is at the basis of all of our synthetic fabrics and plastics and metals. It's just given us a lot of opportunities by understanding matter at its molecular level. So let's look at a molecule. You've probably heard of carbon monoxide. The air contains carbon monoxide as a pollutant. Here is an illustration of a carbon monoxide molecule. This is a model, a representation. There's one carbon atom and one oxygen atom, and they are stuck together. This is carbon monoxide. One carbon atom, one oxygen atom, connected by a chemical bond, which, you could think of as superglue. They're stuck together. The atoms are submicroscopic, meaning they're too small to see with a microscope. Those are the fundamental building blocks of matter, the smallest pieces. My kids are really into Lego blocks. Anybody like Legos? Maybe you secretly do, but you don't want to admit it in front of your college peers. That's fine. We have about a gazillion Legos in our house. Individual Lego bricks are like atoms. Those are the smallest building blocks. You can take those and then you can build all kinds of different things out of them. Free atoms are very rare in nature. There are some like helium and neon, the noble gases that do occur as free individual atoms. But most atoms occur as part of molecules. They get together in specific arrangements to make molecules. Here is an illustration of hemoglobin. This is in your blood, and this is the substance that carries oxygen. You breathe air in, the blood comes to your lungs, the oxygen goes through the barrier there of the blood veins, or this whatever they are. I'm not a biologist. The things in your lungs, right? It goes into your blood. The blood carries that in the hemoglobin to different parts of your body where it's needed. The really nasty thing about carbon monoxide is that it is very similar in size and shape to oxygen. And so it can also bind to the hemoglobin. So you've heard of carbon monoxide poisoning. Every year, people die of carbon monoxide poisoning. And it's very tragic because it's for the most part avoidable. Why carbon monoxide is poisonous is because your hemoglobin, when it gets carbon monoxide, it holds on to it and doesn't let it go. And then it can't carry oxygen. And so you're basically suffocating even though there may be oxygen present. My family had a scare with carbon monoxide poisoning when I was a kid up at a primitive cabin. There was a vent on the gas refrigerator that we didn't even know existed, and obviously it had not been cleaned out for years and years and years. So one morning I woke up with the most horrendous headache you could even imagine. I was convinced that I had a brain tumor and I was going to die imminently, but I also had to pee. And when you're out of your mind with carbon monoxide poisoning, you don't think very clearly, right? So I decided I'm going to die, but I am going to get to the outhouse first. This is very, very primitive cabin. On the way to the outhouse, I fell down several times, and one of those times I fell against the metal shed, and my parents heard me and came out to investigate, and we figured out what was going on. And all of us, were able to get to the hospital and get oxygen, and nobody was seriously injured or died. But we could have all died because the carbon monoxide is heavier than air, and it will slowly fill up the cabin, and you breathe the carbon monoxide, and you don't get any oxygen. This is chemistry, but it also applies to medicine, right, and general safety. Understanding chemistry can help us with a lot of things. So molecules, atoms stuck together. If we want to understand the substances around us, we have to understand the atoms and molecules. Here is a different molecule, carbon dioxide. Very similar name, right? Carbon monoxide, carbon dioxide. The difference is this one has 2 oxygen atoms and 1 carbon atom instead of 1 oxygen atom and 1 carbon atom. Carbon dioxide is present in a larger concentration in the air than oxygen is, and yet we don't have a problem with carbon dioxide because it does not bind to the hemoglobin like the carbon monoxide does. Okay, and I'm not going to test you on this whole carbon monoxide business. It's just an illustration of how the properties of the molecule affect the properties of the matter as a whole and how it affects its behavior. So understanding these particles is the central goal of chemistry. So one definition of chemistry, the science that seeks to understand the behavior of matter by studying the behavior of atoms and molecules, and that's what we're going to do this semester. Any questions?